To write a program that can control your nanomouse from a Bluetooth enabled laptop or desktop, we're going to use processing 2. There are other programming languages you could use, maybe Python or Java, uh, but processing 2 is a good program for us to use because the IDE is very similar to the Arduino IDE. So when you download it, make sure you get the processing 2 version here. Don't go with one of the old versions because it doesn't have the capabilities we need in order to communicate. Once you have it downloaded, just go ahead and open up a blank program or start a new program. So right by clicking new. And then we're just going to draw, to start with, a very simple control panel that just tells us the position of X and Y on the screen. It just prints the value of X and Y on the screen. So to start with, I'm going to create a variable for X, and eventually this is going to store the steering variable, and then Y will eventually store our power variable. After that, just like in Arduino, there's a setup function, and the setup function here is very basic. All you do is tell it the size of the screen, the box that you're creating. Then after that, we're going to create a void draw function, which is essentially the same thing as the loop function in the Arduino IDE. I'm going to set the background to 204, which is a color of gray, a shade of gray. And this background serves to erase our old values in addition to giving a nice background. And then I'm going to use the fill command to color the text that I'm about to draw. And these are just RGB values. So if you change them, you can get different colors. And then I'm going to write some text. And the first bit of text I'm going to write is the X value. So I'm putting an X colon space, and then I'm going to concatenate that with the value of X. And then I'm going to tell it where to put that on the screen, which is 10 pixels over and 20 pixels down. And then I'm going to do the exact same thing for Y. Except I'm going to put it 10 pixels over and 40 pixels down. Once I have those items, it's time to finish the void draw function and create the void mouse moved function. This is a built-in function that is triggered every time the mouse is moved, and I'm going to set X equal to a built-in variable, which is mouse X. And I'm going to set Y equal to a built-in variable, which is equal to mouse Y. And now I have everything I need to run a very simple program that just prints the position of the cursor on the screen right here. If you notice, when I move my mouse to the right, the value gets bigger, and when I move it to the left, it gets smaller. When I move my mouse down, Y gets bigger, and when I move it up, Y gets smaller. And the value 0, 0 is found up in the upper left corner. Now, that's kind of annoying. It's not intuitive to most nerdy math people because it doesn't follow the Cartesian coordinate system. So we're going to go ahead and change that by making some very slight modifications to our code. All we have to do is put minus 100 here, and then 100 minus here. And if I run it again, all of a sudden I see that around the middle of the screen I can find 0, 0, or something close to 0, 0. It's a little hard to find there. But if I move x to the right, it gets bigger. If I move x to the left, it actually turns negative. And when I move y, or when I move the mouse up, y gets bigger. And when I move the mouse down, y gets smaller. It's a little bit tricky to find 0, 0. So let's go ahead and add some lines, kind of like a crosshair to our control panel. I'm going to use stroke to color the lines a different shade of gray. And then I'm going to say line. The starting x position of this line is 0. And then it's going to go through y is 100. The ending x position for this line is 200. And the y doesn't change. So that gives me my horizontal line. And then here the x position is not going to change, but the y position will. So it's going to go from 0 to 200, giving me my vertical line. Now if I go ahead and run my program again, I see some nice little crosshairs, and it's a lot easier for me to get my mouse right towards the middle there. Maybe not perfectly easy, but a lot better. Alright, so now that I have something that makes a little more sense as far as my mouse position, it's time to go ahead and convert the values that I see for x and y, the steering and power variables, into something I'm going to feed into my motors. So I'm going to create a couple new variables. The first one is going to be left motor, and the next one's going to be right motor. And then I'm going to print these to the screen as well, just to make debugging a little easier in case somehow I mess up my math. And so I'm just printing some text to the screen, and then I'm going to concatenate that with the value of the left motor. And then I'll say I want to print this 10 pixels over and 190 pixels down. And I'll do something very similar for the right motor. But this time I'm going to put it, let's see, 130 pixels over. And again, 190 pixels down. And then I need to actually set these values. So down in the mouse moved function, I'm going to say the left motor needs to equal y plus x, and the right motor needs to equal y minus x. And that's just a little trick to convert those values in such a way that when I move the mouse on the control panel, I get power levels that make sense for what I want my robot to do. So if I move my mouse forward, the left and right motors are going to get power to the instructions to make them both go forward. If I move my mouse backward, you can see both the left and the right motors are giving information to make those motors go backwards. If I move my mouse to the right motor is going to go backwards. It's got a negative value, but the left motor will go forward. That'll make the robot turn right. If I move my mouse to the left, the exact opposite happens. Right becomes a positive value, left becomes a negative value, and that'll make my robot turn to the left. So it gives us an intuitive way to control the robot. The one problem is on occasion we get values that exceed 100. You see when I move my mouse up here, the left is getting bigger than 100, and so if I tried to feed that to my robot, I'm going to run into a problem because I'm restricted to sending a byte. It can't exceed 127 or negative 128, something like that. And so I need to somehow clamp these values down. And my receiving program is really only designed to handle values between negative 100 and positive 100. So we're going to have to add a coerce function to this program to get those values to never exceed 100. So right below mouse moved, I'm going to create another function called int coerce, and it's using int instead of void because it's going to return an integer value. It's also going to take an integer value. And the logic for this program is fairly simple. If the value that is fed to it is greater than 100, then we're going to set the value equal to 100. If the value that is sent to it is less than negative 100, then we're going to set the value equal to negative 100. And then we're just going to return that value. And then to use this function, to call the coerce function, we actually need to say the x plus y value, we want to coerce it. And we're going to feed it the y plus x value. And then we also need to do that right here. Now, when I run my program, you can see that the value never gets above 100. Same with over here. When I get down in this area, it never exceeds negative 100. So I'm getting values that are going to be legitimate values to send to the robot and that aren't going to cause problems with the byte requirement that I have to satisfy. There is one issue that I forgot to mention. Let me run this again. You'll notice we already mentioned that it's kind of hard to get the mouse right on top of 0, 0. So I have to get it just perfect. Otherwise, my mouse is going to just creep really slowly, which is kind of annoying. We can fix that by adding what's called a deadband. So I'm going to add one more little piece of logic here that says if the absolute value of the value that we're sending to the coerce function is less than 10, so any number between negative 10 and positive 10, we're just going to say that that's close enough to 0 that we're just going to set it equal to 0. Now, when I run my little control panel, if I get close, it just sets it equal to 0. I don't have to be right on the dot. And when I start moving away from it, I get good values. The next step is to create an array to store the information that I'm going to send. So I have to create another variable, but I'm actually creating a list of variables or an array of variables with this statement, and they're byte type. So I'm going to create message, and it's going to be an array that has 2 bytes in it. It's going to have a byte for the left motor and a byte for the right motor. Okay. Once I have created the storage variable or storage array, I need to feed it information. So I'm going to go all the way back down to my mouse moved function and type message msg0, and I'm going to set that equal to, and then I have to cast it right here as byte left motor, and then I'm going to do something very similar for the right motor. And I have to cast it because the left and right motor variables are integers, and we're turning them into bytes. Okay. Once I've done that, it's time to send the message. So I need to go back up to the top and include a statement to import a library. I'm going to say import processing serial star, and then I need to create a variable, or actually it's an object, a serial object called, I'm going to call it port. And then in the setup I need to actually define how this port's going to work. So I'm going to say port equals, and it's going to be equal to, or I'm going to create this new serial connection with the following parameters. This serial.list, and I'm going to throw a 5 in here. Now I know a 5 works on this computer. This might not be the number that works for you, but I'll show you how to change that or figure out the correct number later. And then I'm going to use the 9600 baud rate. After I include that line of code, I need to include one more line of code at the very end of my draw function to actually send the message. So I write port dot write message, and that should be enough to make my robot drive around. If I try to run it right now, I'm gonna get an error. So before you try anything, I highly recommend you save it. So let's go ahead and do that. I'm gonna say file, save as, and nano mouse remote controller. Just throw it on my desktop. Save. Now that we've written our program, let's go ahead and see it in action. Make sure that your robot is powered on, and then run your program. Oh, here you can see I made a mistake. I accidentally put a dot here that I don't need. Now let's go ahead and try running it again. It'll take a minute to connect, and now it's driving. To figure out what number I should use when I define the port, the settings for the port object within my remote control program, I'm going to create another program that's only 3 lines long. It's going to start out with import processing serial star, and then I'm going to create another port object, and then I'm just going to print some information about that object to the terminal. And I'm going to print the 0th item in the list just to get started here. And what I'm looking for is something that says dev tty dot, and then the name of my module. So I'm going to go ahead and run this for the 0th item in the list, and I see that down here it says dev/cu.bluetooth-incoming port. That's not what I'm looking for. So I'm going to switch this to a 1 and run it. That's not what I'm looking for. I'm going to try again. And this looks pretty close because it says jy-mcu back. That's that's the name of my Bluetooth module, but it's got the CU here, so that's not going to work. I'm going to stop that. Try 3. That's not correct. Try 4. Still no go. And finally, we see here where it says tty.jy-mcu backus, and then it appends it with this -devb. At any rate, this is the number. This 5 is what corresponds to the correct port associated with my Bluetooth module when I paired it. On a Windows computer, click the Start button and then Devices and Printers. Click on the icon associated with your Bluetooth module and click the Hardware tab. You will see a COM port assigned to your Bluetooth module, in this case COM4. As you can see, I've already plugged a 0 into the print serial list portion of this program. So we need to see if COM4 is associated with that 0. And so we go ahead and run it, and as luck would have it, first try.